When looking at percent composition in an empirical formula, in addition to analyzing standard molecules which just contain like carbon, hydrogen, oxygen, or ionic compounds, we can also look at substances known as hydrates. Now hydrates are molecules, ionic compounds that have water embedded within their crystalline structure. But they're still solids. Even though there's water present, it is not in a liquid or aqueous state. So when we're analyzing them for their percentages, usually what we're looking for is the percent that's anhydrous and the percent that is water. So if you're given a formula for a hydrate, in order to determine the percent water, you do it just the same way you do any percent composition. You figure out the portion that is that type of thing out of the whole. And since we're looking for the percent water, we need to figure out what the whole thing weighs and figure out what percentage of that would be water. So copper, molar mass, how many you have in the substance. Sulfur, molar mass, how many you have. Oxygen in the copper sulfate. I want to keep this oxygen separate from the oxygens in the water, just so I can look at water as its own animal. So oxygen 16 times the 4 that you have present in the compound. That gives you the molar mass of the anhydrous component. Then we look at the waters that are attached separately. Each water consists of 2 hydrogens and an oxygen, so that gives you a molar mass of 18.02. Since there are 5 waters embedded in this structure, that gives you a molar mass of 90.10. So if out of this whole hydrate, the molar mass would be 249.71 grams per mole of that substance. So out of that 249.71 grams, 90.1 are from water. So this means that the hydrate would be 36% water, and it would be 63.92% the anhydrous or copper sulfate component. Another way we can approach these problems is if you're given a percentage that's water, and I ask you to figure out the formula, or basically determining the empirical formula of the hydrate. So the example I put up here is like magnesium sulfate forms a very common hydrate, and it contains 51.17% water. So that also implies that it contains 48.83% anhydrous substance. So since we know the formula for that, what we can do is still figure out how many moles of that we have, and given the percent water, we can figure out how many moles of water we have. Again, remembering that whenever you're given a percentage, you just need to convert the percent sign to grams in order to get to moles. Then when you have grams, you can always go to moles. So 48.83 grams of magnesium sulfate, that being the molar mass, gets you 0.4057 moles of magnesium sulfate. For that many moles of magnesium sulfate, assuming that's grams, you divide by the molar mass of water, and you get 2.840 moles of water. So whenever you're looking to establish a ratio, what you're going to do is divide by the lowest number present. So in this case, that's 0.4057. And that would give you, for every 1 mole of magnesium sulfate, you're going to get 7 moles of water. So given that, and comparing the two things, you can get the empirical formula, or the formula of the hydrate, to be MgSO4.7H2O. So just like when you're doing empirical formula for substances where you're looking at different components, you're only looking at the elements in other samples. In the hydrates, we're kind of separating the anhydrous component and the water component instead of the individual elements.